In this video we're going to look at concentration. The first thing I'd like you to do is kind of describe how these images link to concentration and where would be high and low concentration, what those words mean. So what does concentration mean and how are they different in these images? Okay, so you should have paused the video and had a chance to have a go at looking what these are. Here we would have really high concentration for juice because there's a high concentration of juice particles, which means there's lots of juice particles in comparison to the water particles in this beaker, whereas in this glass down here it's a low concentration of juice because there is less juice particles than there are water particles. So concentration is talking about how many particles of that thing there is per the water. So water can dilute things down and it can make it less concentrated. So you can start off with something fully concentrated with no water added, and you can then add water, and we can calculate this by if we know the amount that we've added to it, so the amount of grams we've got. So here we've got the amount of solute in grams, so the amount of that thing that we're measuring the concentration of. If we've got that in grams, we can divide that by the volume of that solution, and that will work out how many grams of the solute per the whole solution that we have, and that's the concentration. And concentration is measured in grams per decimeter cubed. Now decimeter cubed is a new unit, you might not have used it before. I will go into a little bit more detail of what it is soon, but it is a larger version of a centimetre. So there are 10 centimetres within a decimetre. So with that in mind, and you should have written that equation down, so if not you might want to skip back and write it down. I'd like you to have a go at these. I can do the first one with you. So 15 is the mass and the volume is 0.5 decimeter cubed. So I'm going to do 15 divided by 0.5 because we do mass divided by volume to get us concentration, and that will give us 30 grams per decimeter cubed. So here I would write 30 grams per decimeter cubed. Pause the video, have a go at the rest, and I'll go through the answers with you. So you should have had a chance to go through the answers. Second one is 65 divided by 23, which would give you an answer of 2.82 grams per decimeter cubed. The third one is 50 divided by 2.6 decimeter cubed, so you would get 19.23 grams per decimeter cubed. The final one, 45 divided by 2.5, will give you an answer of 18 grams per decimeter cubed. So that's quite straightforward. You just do mass divided by volume. So what is the difference between centimetre cubed and decimeter cubed? Because you might be asked in an exam, work out the mass of something and the volumes given to you in centimetre cubed. Now we have to convert it into decimeter cubed. It's really important that we're calculating concentration when the volume is in decimeter cubed rather than centimeter cubed. So what is a decimeter? Now I've drawn this not to scale diagram of a ruler. I've got my centimeters here, and let me get the pointer. So I've got my centimeters here, and there's a little arrow saying that that's 1 decimeter. So 1 decimeter is 10 centimeters. So if I was to write this here, 1 centimeter cubed, just 1 centimeter equals 0.1 decimeter, because that 1 centimeter from there to there is 1/10 of a decimeter. Now we're talking about centimeter cubed and decimeter cubed. So rather than just divide by 1000, that we had to do here to get from 1 centimetre to 0.1 decimetre, you have to divide by 1000 because of these cube numbers. So for example, 1 centimetre cubed equals 0.001 decimetre cubed. So you have to divide it by 1,000 to get from centimetre cubed to decimetre cubed. And you don't need to understand why we're dividing it by 1,000. It's just nice to understand what a decimetre actually is in comparison to those centimetres on your ruler, because we don't often use them. So with that in mind, I'd like you to have a go at these. The first one, 15 divided by 1,000. Well, that's going to give you an answer of 0.015 decimetre cubed. So I would write that up here. Have a go, pause the video, have a go at the rest, and then we'll move on to some questions. So you should have had time now, so that would be 0.065. This one would be 0.05 and 0.045. So we've been able to convert from centimetre cubed to decimetre cubed. It's simply simply dividing it by 1,000. So what I'd like you to do is have a go at these worded questions. It isn't as clear because it's not come out as well as I hoped when I wrote these out. They've missed out some of the units. So it says, when Ben puts 50 grams of salt into 409 decimetre cubed of water, what is the concentration of Ben's solution? So there the concentration is in the right units, so you would just do a divide, whereas the next two are in centimetres cubed, so you're going to have to convert those to decimetre cubed before you can calculate the concentration. So have a go at these questions, pause the video, and then we're going to go through it. Okay, so you should have had a go at the first one. So you do 50 divided by 409, which will give you an answer of 0.12. We'll just do 2 decimal places, grams per decimetre cubed. This next one, you're going to do 4.5 centimetre cubed. You need that in decimetre cubed, so you're going to have to divide by 1,000, which will give you 0.0045. You're then going to do your 3 divided by 0.0045 to get an answer of, so 3 divided by 0.00 would give you an answer of 667 grams per decimetre cubed. Final one, so if you put 8.9 grams of salt into 340 centimetre cubed, well, you're going to have to change that. 340 centimetre cubed divided by 1,000 will give you 0.34 decimetre cubed, and then you're going to do your 8.9 divided by 0.34 to give you your answer in grams per decimetre cubed. So it'll give me a second. 8.9 divided by 0.34 will give you 26.2 grams per decimetre cubed. So just mark those answers, check you've got them right, and we're going to move on to the last type of question you might be asked. And that is when they've got the concentration and that they might need or that they've got in that beaker, and they want you to work out the mass of solute for a certain volume. So you need to know this other equation, which is just the rearranged version of the one we've been using so far, which is mass equals volume of solution in decimetre cubed multiplied by concentration, which is grams per decimetre cubed. So you're multiplying the numbers this time. you need to be aware that the decimeter cube still needs to be, so the volume of a solution still needs to be in decimeter cubed. So if you see centimeter cubed, you need to make sure you're dividing by 1,000 before doing the multiplication. So let's do the first one together, which was the example that we've just gone through there. So it was the beaker had 3 grams per decimeter cubed, and we needed to work out how many grams that was needed for 0.5 decimeter cubed. So you would do 3 multiplied by the 0.5, which gave you 1.5 grams. So the mass of the solute was 1.5 grams. Pause the video now, have a go at the next 3, just be aware of this one, and we'll go through the answers in a moment. Okay, so you should have done this one. It's 23 times 5, which would give you an answer of 115 grams. That's a simple multiplication. So is the next one, because you do 2.6 multiplied by 3, which would give you 7.8 grams. And finally, this one, you need to do, I'm just going to do the working out here, 2.5 centimetre cubed, divide it by 1,000, would give you an answer of 0.0025, and that's in decimeter cubed. And then what do? You multiply the numbers together. So you multiply this by 1, which gives you 0.0025 grams. So the final way that you would see it, and this is the exam style question, it's asking for the same thing. It's asking you to calculate the mass of solid copper chloride used in each experiment. So it says the copper chloride solution used in the investigation contained 300 grams per decimeter cubed. Like that. Okay, they've written it out in words, but that's what it looks like. So that's the concentration of solid CuCl2 dissolved in 1 decimeter cubed of water. The students used 50 centimeter cubed of copper chloride solution in each experiment. Calculate the mass of solid copper chloride used in each experiment. So what you need to do is you need to work out the volume in decimeter cubed, and then you need to multiply it by the volume, by the concentration, which will give you the mass per that volume. So have a go yourself at that one.